7-4, division properties of exponents. So our objective for this section is to divide powers with the same base and to raise a quotient to a power. And we can use the properties of exponents to divide powers with the same base. Okay, so we can take the idea of repeated multiplication to simplify quotients of powers with the same base. So if we expand the numerator 4 to the 5th power, which means 4 multiplied by itself 5 times, 1, 2, 3, 4, 5, and we take 4 divided by 4 to the 3rd power, you can see that the 3rd power, 3 of the ones on the bottom, cancel with 3 of the ones on the top to leave me with 2. So if we take this idea of how the division of exponents or with terms with exponents works, we can make a rule. So to divide powers with the same base, subtract the exponents. So in an algebraic form, right, if a to the m power over a to the n power becomes a to the m minus n, where a is not equal to 0 and both m and n are rational. Okay, so that means 2 to the 6 over 2 squared becomes 2 to the 6 minus 2 power, which is 2 to the 4th. And x to the 4th over x to the 7th becomes x to the negative 3rd power, which then we would move to the bottom of a fraction. And this also works for rational exponents, fractional exponents, okay? 3/4 over 1/2, we are just going to subtract. Of course, remembering that we need to change to a common denominator to be able to subtract. All right, let's see how this works. What is the simplified form of each expression? So this expression right here, I'm going to start by taking the exponent in the numerator minus the exponent in the denominator. And then I'm simply going to simplify this by making these have a common denominator of 2, which gives me x to the positive 1/2 power. And since my exponent is positive, I can stop right there. Let's look at b. Let's take both of these separately, right? Because different variables, got to treat each separately. So this would be m to the 2 minus 5 power times n to the 4 minus 3 power, which gives me m to the negative 3, n to the first. And then when we have a negative exponent, it moves to the bottom of a fraction. Whoops. When it moves to the bottom of a fraction, it then becomes positive. That was the point. Let's look at some kind of problems. So with both of these, with all these, subtract the exponents. Okay. So for the first one, we have y to the 3 over 4 minus 1/2, which is 2 over 4, to give me y to the 1 over 4 power. Positive, good, we're done. B is d to the 7 over 2 power minus 3, which is d to the 7 over 2 power minus 6 over 2, which is 3, to give me d to the 1/2. For part C, we're going to remember to treat both of these separately. So that's k to the 6 minus 1, j to the 2 minus 5, so k to the 5th, over, let's just do both of these, j to the 3rd, right? J to the negative 3, then I would move it to the bottom of a fraction. Now just be careful with this one, with part D, that just don't get messed up with the signs. A to the negative 3 minus 5, and b to the 7 minus 2. Negative 3 minus 5 is negative 8. So that's a to the negative 8, b to the positive 5, and the negative exponent goes to the bottom of a fraction. Now, if you had wanted to, you could have moved this negative exponent term to the bottom of the fraction and then added the exponents together on the bottom. That's another way to do this, but let's stick with this technique for now. X to the 4 minus 4 power, y to the negative 1 minus a negative 5, and z to the 8 minus 1. Oof, squeezing that in a little bit there. X is easy. It goes to 0, which means it turns into a 1, which means it just goes away. Negative 1 minus 5 is going to be negative 6. So that's y to the negative 6 power, z to the 7th power. So my answer becomes z to the 7th over y to the 6th. Okay. We can use the property of dividing powers with the same base to divide numbers if they are in scientific notation. Okay, so population density describes the number of people per unit area. So it's people divided by area. During 1 year, the population of Angola was 1.21 times 10 to the 7th people. The area of Angola is 4.81 times 10 to the 5th miles squared. What's the population density? Okay, so that means that we are going to take 1.21 times 10 to the 7th divided by 4.81 times 10 to the 5th. Okay. So I can rewrite this. First, I'm going to have to divide the numbers because I need to know what 1.21 divided by 4.81 is, times 10 to the 7 minus 5 power. Okay, so instead of turning these into big numbers, we can manipulate them in scientific notation the way they are. 1.21 divided by 4.81 is 0.25 times 10 squared, which is, of course, that's not right in scientific notation, but this is such a small number that we don't really need scientific notation. 0.25 times 10 squared is just about 25. So it's about 25 people per mile squared. During one year, Honduras had a population of 7.33 times 10 to the 6 people. The area of Honduras is 4.33 times 10 to the 4th miles squared. What's the population density? So again, 7.33 times 10 to the 6th divided by 4.33 times 10 to the 4th. We're going to divide the numbers and subtract the scientific notation exponents. 7.33 divided by 4.33 gives us about, rounding, 1.69 times 10 squared. Again, we can just rewrite this as 169 people per square mile. So a little bit more dense than the last problem. Quotient to a power. We can use repeated multiplication to simplify a quotient raised to a power. So similar to raising just one term to a power, we're going to raise the top and the bottom. So it becomes x over y times x over y times x over y, where we would add those exponents together and get x to the third, y to the third. So this suggests another property of exponents, which is raising a quotient to a power. When you raise a quotient to a power, raise the numerator and the denominator to the power and simplify. So it's kind of like you're distributing this exponent to both of the things inside of the parentheses, to both of the pieces of the fraction. Okay, so in the example, 3 over 5 is 3 squared, or 3 to the third over 5 to the third, 27 over 125. Both of these get raised to the 5th power, and both of these get raised to the 1/2 power. So what is the simplified form of z to the 2 over 3 to the third over 5 to the third power? So we have z to the 2/3 over 5 all to the third power, which becomes z to the 2 over 3 to the 5th power over 5 to the 5th power. Whoops. 5th power, third power. There we go. Okay, so now when I raise 2 over 3 to the third power, I multiply the exponents together. 2 over 3 times 3 gives me z squared. And then 5 times 5 times 5 is 125 to give me an answer of D. Let's try some guided problems. What is the simplified form of 4 over x to the third squared? Raising both of these to the second power gives me 16 power to a power. We multiply the exponents together, so it's x to the sixth, not x to the fifth. Don't add, you multiply. Describe two different ways to simplify the expression a to the 3/4 to the fifth. Well, we could raise both of these to the fourth power like we just did in this problem, or we could subtract the exponents first and then raise my answer to the fourth power. Personally, with this fraction right here, I think raising it both to the fourth power first would probably be a little bit easier, and then subtract the exponents. That way you don't have to subtract fractions. We can also write an expression in the form a over b to the negative n power using positive exponents. So if I work this out, if I have a over b to the negative n power, that's the same thing as 1 over a over b to the positive n power. Then I use the property that we just saw to raise both of these to the n power. And then when you have a number divided by a fraction, that's the same thing as multiplying by its reciprocal. So I take the numerator 1 and the reciprocal of the denominator, and since both of these are raised to the n power, I can now factor it out. And look what happens. A over b to the negative n power is equal to b over a to the positive n power. Okay? And that is not necessarily one of our properties, but a nice little trick that we can use to help us. So if I were to take this problem and I was to raise everything to the negative 3 power, I would have a bunch of exponents now that were negative that I would have to move to the bottom or to the top of a fraction. Can get a little confusing. Easier to use the technique that we just saw, that if we take this entire expression, if it's raised to the negative 3 power, I can flip the fraction, keeping everything together, and it makes the exponent a positive 3. And now, raising everything to the positive 3 is a little easier, because we get y power to a power, multiply exponents. 2 times 2 times 2 is 8, and x to the 18. Okay? Let's look at another one of those. Again, flip the fraction, 5b over a, and raise it to the positive 2 power, which gives me 25b squared a squared. And then, of course, look and see if there's anything else I can simplify or cancel out, which there is not. All right, so simplify each expression, subtract the exponents there, raise everything to the third power, flip this over n over m to the positive third power, and flip this whole fraction over to simplify easily. For this one, right, divide 7.56 by 2.78, and it will be times 10 to the first power. 6, vocabulary. How is the property for raising a quotient to a power similar to the property of raising a product to a power? Same idea, is that we're taking everything, right? Product to a power would be something like this, would be a to the third, b to the third, and quotient to a power is what we just saw, a to the third, a to the third over b to the third. So basically we're taking this 3 and we're giving it to everything inside of the parentheses. Doesn't matter if it's a product or a quotient. Ross simplified a over a to the third over a to the seventh as shown. Not correct. You take the numerator minus the denominator. Okay, and so this would give you, oh, that does actually work. Okay, so why does it work? Because you're taking this, bringing it to the bottom of a fraction. So basically what you're doing is you're taking this a to the third, you're bringing it to the bottom of a fraction, and you're changing the sign. So now you're adding these two exponents together. Uh, Different way to kind of look at this, but it still can work, and you're actually bringing the smaller exponent down to the bigger one, which is a useful technique. Write a quotient of powers and use the above method to simplify it. Yeah, okay, let's take a look at this. Let's go x to the 6th power over x to the 10th power. So our first method would say 6 minus 10 is negative 4, and then we would have to move that to the bottom of a fraction. So what we're saying here is we can take the 6 and move it down to the bottom of a fraction and make it negative. And now we can combine the exponents with addition, subtraction in this case, to give me 1 over x to the 4th power. And that is 7-4, division properties of exponents.